Equivalent equations. In this video, you'll learn how to tell whether two expressions are equivalent and explain why or why not. You'll also learn how to identify the moves that can be made to transform an equation into an equivalent one. Equivalent equations are equations that have the same exact solutions. We can create equivalent equations by using properties of equality, such as adding, subtracting, multiplying, or dividing both sides by the same number. So if we have the equation 2x plus 4 equals 10, and we subtract 4 from each side, then we get 2x equals 6, which would be an equivalent equation. Now if we divided both sides by 2, we get x equals 3. That all three of these equations are equivalent. Now let's look at recognizing equivalent equations. Equivalent equations can look different but represent the same relationship. Solving each equation to see if they simplify to the same value will help us determine if two equations are equivalent. Let's determine if these two equations are equivalent by solving for x and determining if they have the same value. We'll solve the first equation first by subtracting 6 on each side. This gives us 3x is equal to 6. Now we'll divide both sides by 3, which gives us x equals 2. Now let's solve the other equation. We'll start by subtracting 2 on each side. This gives us x equals 2. So we can see that x equals 2 for both equations, so these are equivalent. Which equation is equivalent to 6x plus 9 equals 12? Let's start by finding the solution to our given problem. We'll start by subtracting 9 from each side. This gives us 6x equals 3. Now we'll divide both sides by 6, which gives us that x equals 1/2. So we'll go through each of our options to see which one also gives us an answer of 1/2. We'll start with x plus 9 equals 6. We can solve for x by subtracting 9 on each side. This gives us x is equal to -3, which is not the 1/2 that we wanted. So this is not an equivalent equation. Now let's look at 2x plus 3 equals 4. We'll start by subtracting 3 on each side. This gives us 2x equals 1. Now we'll divide both sides by 2, which gives us x equals 1/2. Since this matches our original solution, we can say that 2x plus 3 equals 4 is equivalent to 6x plus 9 equals 12. Here's another example. Which equations have the same solution as the equation 3x minus 12 equals 24? Let's start by solving this equation so we know what its solution is. We'll start by adding 12 to both sides of the equation. This gives us 3x is equal to 36. Now we'll divide both sides by 3, which gives us x equals 12. So we'll see which of the other equations also produce a solution of x equals 12. We'll start with 15x minus 60 equals 120. We'll solve for x by adding 60 to both sides first. This gives us 15x is equal to 180. Now we'll divide both sides by 15, which gives us x equals 12. So this matches our original solution. So this is an equivalent equation. Now let's look at 3x equals 12. We can solve this equation by dividing both sides by 3. This gives us x equals 4, which does not match the 12 that we had in the original equation. So this is not equivalent. Now let's look at 3x equals 36. We'll start by dividing both sides by 3 again, which gives us x equals 12. So this matches our original solution. So it tells us this was an equivalent equation. Now let's look at x minus 4 equals 8. We'll solve for x by adding 4 to both sides. This gives us x equals 12, and this matches our original solution. So this is another equivalent equation. Now let's look at 12x minus 12 equals 24. We'll start by adding 12 to both sides of the equation. This gives us 12x is equal to 36. Now we'll divide both sides by 12. This gives us x equals 3. So since it doesn't match our original solution, this equation isn't equivalent. Let's look at one more example. Jamie has a coin jar containing N nickels and D dimes worth $3.65. The equation 0.5N plus 0.1D equals 3.65 is one way to represent this situation. Let's create an equivalent equation without decimals. So let's start by bringing our equation down. Since we want our new equation not to have any decimals, we'll need to multiply by the biggest decimal value that we have. So we have 5 hundredths, 1/10, and then 3 and 65 hundredths. So since our biggest decimal value is hundredths, we'll multiply the entire equation by 100. If we multiply both sides of our equation by 100, we'll get 5n plus 10d equals 365. So now our equation has no decimals, and since we multiplied everything by the same value, this is an equivalent equation. Let's recap what we've learned. Equivalent equations are equations that have the same solutions. We can create equivalent equations by applying the equality properties of all operations. We can verify if two equations are equivalent by solving each equation to see if they have the same solution.